Hi guys, in this episode of Shri series, we're going to be talking about what Ohm's law is, and then I'm going to show you the formula to calculate Ohm's law. All right. Now, we know very well this topic is involved in electricity. All right. So when we talk about electricity, we talk about circuits. When we're designing circuits, we look at also certain circuit components. So I'm not here to talk about what circuit components are. We're here to discuss how Ohm's law works. All right. So there are three things you need to understand. What you've got to know is there's current, there's voltage, and there's resistance. All right, current, voltage, and resistance. Now, as you know very well, current is represented by I, and it's measured in amps. Voltage is represented by V, it's measured in volts, and resistance is represented by R, and it's measured in ohms. All right, so I'll just show you the symbols. So A for amps, V for volts, and ohms for resistance. All right, so what does Ohm's law firstly state? All right, now you got to understand that in order for you to define Ohm's law, you need to incorporate these three components mentioned here. All right, so what does Ohm's law state? All right, so what Ohm's law states that under constant temperature, current is directly proportional to voltage. All right, so that's what Ohm's law states. So key points to understand is that you need to have a constant temperature, and when your current is increasing, there is also a proportionate increase in voltage. And that's literally what Ohm's law states. Okay, so having explained what that is, so we now know that in a circuit, all right, you increase your current, your voltage is going to increase. All right, now let's write down the formula. Okay, when you get voltage and divide that by your current, you get what's known as resistance. All right, so resistance is actually voltage divided by your current. Okay, now there are key things you need to understand by looking at this equation. You can say that your resistance is inversely proportional to your current. All right, so what that means is when you're increasing your current, okay, your resistance will reduce. Okay, now if you think of it like in basic terminologies, what that states is the purpose of resistance is to prevent excessive or unnecessary current from flowing through. All right, so resistance is simply defined as the opposition to the flow of current. Okay, so what it states that your current is directly proportional to your voltage, but inversely proportional to your resistance. All right, so just remember, I'm referring to ohmic conductors. We're looking at conductors that follow Ohm's law. All right, so this is just a basic understanding. We will look at resistors in series, resistors in parallel. I just want to introduce to you this formula. All right, so resistance is voltage over current, and I know we use the pyramid here, this case, just to show you how we can represent them. So we can put resistance there, we can put voltage, and we can put current. And what that tells you is, firstly, resistance is voltage over current. Voltage is current times resistance, and current is voltage over resistance. So you can see even from this formula, you can tell that your current is directly proportional to your voltage, but inversely proportional to your resistance. All right, so this is how you calculate, or this is the formula required to calculate resistance. That involves voltage and current. Resistance is voltage over current. Voltage is current times resistance, and current is voltage over resistance. All right. In the next set of videos, we're going to be looking at calculations involving Ohm's law. All right. Thanks guys for listening. Bye now.